This is lesson 5.4, Indirect Proof. Your objectives are to write indirect algebraic proofs and to write indirect geometric proofs. One way to prove that a statement is true is to temporarily assume that what you are trying to prove is false. By showing this assumption to be impossible, you prove your assumption false and the original conclusion true. This is called an indirect proof. To do this, assume the conclusion is false. So whatever you're trying to prove, assume the opposite. Then show that that assumption is impossible. It will lead to a contradiction of the hypothesis or some other fact. And since the opposite is false, then the original conclusion must be true. You can also do indirect proof with geometry. The process is still the same. Assume that the conclusion is false. Show how that leads to a contradiction and it's impossible. And since the opposite is impossible, then the original statement must be true. State the assumption you would make to start an indirect proof of each statement. If the measure of angle A equals 90, then the measure of angle B equals 45. Well, we need to assume the opposite of the conclusion. And the opposite of the conclusion would be that the measure of angle B is not equal to 45. If we were to continue this proof, we would show how that leads to a contradiction. And since it would lead to a contradiction, then the assumption would be false, so the original statement would be true. Number 2, if segment AV is not congruent to segment VE, then triangle AVE is not isosceles. Well, let's assume the opposite of the conclusion. The conclusion is triangle AVE is not isosceles, so we will assume that triangle AVE is isosceles. Complete the indirect proof. Angle 1 is congruent to angle 2, and segment DG is not congruent to segment FG. Prove that segment DE is not congruent to segment FE. Well, since we have two triangles, and I'm talking about segments being congruent or not congruent to each other, and I can see down in step 5, they're guiding us to say, let's prove the triangle's congruent. Let's think that way. Let's do what it takes to prove the triangle's congruent, and then see where the assumption becomes impossible. So start by assuming that the conclusion is false. The conclusion says segment DE is not congruent to segment FE. So let's assume that segment DE is congruent to segment FE. So now we have a pair of congruent sides and a pair of congruent angles. What else do you know about these two triangles? Well, they share a side, and that side is congruent to itself. So segment EG is congruent to segment EG. That's the reflexive property. And now for those triangles, I have a pair of sides, a pair of angles, and a pair of sides. Those triangles are congruent because of side, angle, side. Now, if triangles are congruent, then all of their parts have to be congruent, which means all the corresponding segment pairs and all the corresponding angle pairs have to be congruent. One of those segment pairs is segment DG and segment GF. So I can say segment GG is congruent to segment FG. Because corresponding parts of congruent triangles are congruent. However, we're given that segment DG is not congruent to segment FG. So if that's the case, we have a contradiction. Our assumption is impossible. And if our assumption is impossible, then the original must be true. So this contradicts the given information. The assumption must be false. Therefore, segment DE is not congruent to segment FE. So with an indirect proof, assume the opposite of the conclusion. In this case, we are trying to prove two segments that are not congruent, so we assume that they are. And because of what we already know, if those segments are congruent, then the triangles are congruent. And if those triangles are congruent, then all of the corresponding parts are congruent, including segment DG and segment FG. However, we were given that segment DG is not congruent to segment FG. So that's our contradiction. The assumption is false, so the original statement must be true. So whenever you do an indirect proof, assume the opposite of the conclusion. Show how that's impossible, and if the opposite is impossible, then the original must be true. When you assume the opposite, it will eventually contradict, either with the given information or with some other mathematical rule. Once you reach that contradiction, you know the assumption is false. And if the opposite is false, then the original statement must be true.